we are going to talk about polynomial and rational inequalities. So with inequalities, what you're looking for is for a range or interval where the graph is either greater than or less than the x-axis. So these are the steps for finding the inequalities for both polynomial and rational. The first thing you want to do is factor if possible. So I'm going to go ahead and factor this equation. In order to factor, we have to set it equal to 0. So I'm going to move everything to one side. And when you move it over, that would change the signs, and then it will be greater than 0. So we're trying to figure out where is this equation greater than 0. So in order to factor with this four terms, I'm going to factor by grouping. So take out the greatest common factor of each pair. Remember, these should be the same if we did it correct. So we have x squared minus 4. Whatever's on the outside is 1. And then what's on the inside is the other, making sure they're the same. And then lastly, we can even factor this more, because that's a difference of squares, to x minus 2, x plus 2. And then we have the x plus 4. So we are looking where this is greater than 0. That's our goal. So the first step is then we factored. Then we find key points. What that means is you want to take every factor, set it equal to 0, and solve. So x minus 2 equal to 0, x would equal 2. Here, x would equal negative 2. And here, x would equal negative 4. Those are going to be our key points, and we're going to put these on a number line. So over here, I have negative 4 would be first, then negative 2, and then positive 2. So I'm going to test these intervals. I'm going to test from negative infinity to negative 4, in between here, and 2 to infinity, to see where is this going to be. The question is greater than 0. So this says test for positive or negative. So I'm going to pick points in each interval. So I'm going to pick the point, I'm going to test the point negative 5, because that's on this side of negative 4. I have to pick a point in between here. That would be negative 3. And again, there's multiple or infinite number of points you can choose. A point in between these two, I'm going to test 0, and then a point greater than 2, I'm going to test 3. So you can choose any numbers that fall in those intervals to test. What you're going to do is you're going to put this point into your factored equation and see if you get a positive or negative number. So if I put negative 5 into this equation, I would get a negative number. If I put it into this equation, I would get a negative number. And if I put it into this equation, I would get a negative. A negative times a negative times a negative is a negative number. So on this side, this interval is going to be negative. Then I do the same with my other points. So again, if I test negative 3, here that would be a negative. Here that would be a negative, and here that would be a positive. So negative times a positive is a positive number. Now if you go through and do the same thing with 0 and 3, you'll get that this is a negative and this is a positive. So you just plug it in to test it. Now all I have to do is answer the question. The question is, where is this greater than 0? Greater than 0 would be the positive numbers. So it's greater than 0 in between here and here. So my final answer would be from negative 4 to negative 2 in union with 2 to infinity. That would be my final answer. And the reason that I'm using open circles and parentheses is because it's greater than 0 and not greater than or equal to. If it was equal to, then I would have brackets. Now you could check this by looking at the graph. So this is the graph of that equation, just a rough sketch. So you can see that we're asking where it's greater than 0. It's greater than 0 right here, which again is between negative 4 and negative 2, and then right here, from 2 to infinity. If it asked where it was less than 0, then your intervals would change, and it would be the places where it was below the x-axis. So we're going to do the same step with a rational inequality. So I've already factored, and then we find the key points. So we set everything equal to 0 and solve. So this would be negative 3, this would be 1, this would be positive 3, and this would be negative 2/3. I'm going to put those numbers on a number line. So negative 3 would be first, negative 2/3, positive 1, positive 3. Now, the reason why some are going to be open circle and some are actually going to be closed is because of this right here. So this is asking for where it's less than or equal to. So normally you would have, if it was just a polynomial, all of those things would be closed circles. However, you cannot have 3 and negative 2/3 are not part of the domain, because you can't have those as answers. So those have to be open circles because you can't have a 0 on the bottom. All right, so we're going to do the same thing. We're going to test points in each interval. So if I test points to the left, I'm going to test, let's say, negative 4. I'll test the point, we'll say -1. I'll test the point here, we'll do 1/2, and then see 2 and 4. Just choosing different points on each interval, and then you will go ahead and plug it in to see if you get positive or negative values. So here, if I plug in -4, I would get a negative and a negative. Here I would get a negative and another negative, so 4 negatives. 2 multiplied, that'd be a positive. 2 multiplied would be a positive. A positive divided by a positive is a positive. Go ahead and do the same with all of these points, and if you do that, this is what you will get. Now this question is, where is it less than or equal to 0? So it's less than, it's negative here and here. So our answer would be these intervals. So it would be -3, because it wants to know where it's equal to. But again, -2/3 has to be a parentheses, because that can't be part of the solution, because it's not part of the domain. And then in union with 1 to 3. So that would be my answer. And then lastly, we could check on the graph. So we have this graph here. So we are looking again where it's less than or equal to 0. So you can see from here, from -3 down to 2/3, it's below the x-axis. And then from 1 down to 3, and that goes to there, it's below the x-axis. So that would be our answer.